So thank you for a nice invitation, and I'll just go quickly through a number of diverse points, but you will discover that I think there is some space for biofuels, but I'm not too excited about it. So let me start, but my focus now will be quite a lot from the perspective of transport and transport's energy needs. So you'll see that I've worked on that from various perspectives. The only one which is missing is biofuels. This is from a database on energy use in transport. And what we are seeing here is countries sorted from poor to rich. And it is only domestic transport. So that means the transport that doesn't cross any national borders. And that transport represents 28% of energy use in OECD countries. If you look at it here, you will see that there is a tendency that it is less in poor countries. Another thing you can see is that domestic transport is absolutely only road. It's almost nothing else. It's like Norway is an exception. There is actually some maritime shipping here. And then there are some other countries where rail takes a good portion. But let's say the exceptions to the road only are countries that are big and poor. Then it'll be quite a lot of rail, or have a lot of coastline. Then it'll be some maritime transport. So in this latter bundle comes Norway, Indonesia, and the Philippines. But basically 28% of world energy use is domestic transport. And that means that if you add to it international transport, which is maritime shipping, about 2 or 3% of global CO2 emissions, and aviation, which is 2 or 3% of global CO2 emissions, transport is up to a third of fossil fuel use, around a third. So there is no doubt that those who are saying, we can't decarbonize transport, they have to be wrong. So that's kind of why I have worked on transport for a while. This is from work with naval architect Lindstad in Trondheim. Basically, many of you have seen that transport is taking an ever larger role, and they blame it on globalization. And I'll also tell you that that's no reason for pessimism, because the kind of transport, the measurement of transport that goes through the roof is the value of transported goods. If you look at ton miles, you get closer to energy consumption and closer to greenhouse gas emissions. Then you'll discover that maritime shipping, which by the way is all of trade, there's nothing else. There's air freight, for instance, have nothing to do. Then you'll discover that transportation work in these years of globalization has not expanded more, but at exactly the same pace as world GDP or world output. So there is a efficiency gain in transport here. In addition, there is greenhouse gas emission reductions per ton mile done, which is much because of lower speeds and larger ships. Cargo freight is only maritime transport. So this is global cargo freight, meaning domestic too. So here you also see some road and some rail. But a big picture is that the tough climate policy would be like high fuel prices. Okay? It would take transport from air to surface, from road to rail, and from rail to sea. It would slow down speeds. It would transport us in larger lots. So let's say in buses rather than cars. And maritime transport would be a winner, and maritime transport would change, but much of it actually is slower and larger, and better hull shapes and things like that. In addition, there's going to be other energy carriers and technologies, but the big picture is slower and larger. That you can see in this one. So this is actually freight. And if you compare down here, you can see there's huge reductions in CO2 emissions per ton kilometer transported. And each of these either are due to larger lots or slower speeds. So we have found, and the same is for passengers actually. So here is large car at low capacity utilization. Here is a large car at high capacity utilization. Here is small car at low capacity utilization, meaning one seat, etc. And then we're kind of getting emissions per passenger kilometer down as we are expanding the vehicle or as we are slowing down. So this is fun for me because it's much about efficiency and the efficiency in the transportation system. All of this is in addition to what you can do when you take other energy carriers, other technologies, etc. In Norway, transportation is about a third of greenhouse gas emissions. In Norway, these are within country transport. You can see we do about 40% of the ton-mile work in maritime, 10 in rail, 50 in road, and that's it. And I use both this one and for passengers, show that road is dominant to argue that, of course, we actually need to get the emissions out of road vehicles if we want to be as climate friendly as politicians say that we shall be. Here's what we do with cars. We're basically, for an economist, this is unorthodox in the sense that we don't write about this in environmental economics textbook. But this is a tax that applies to the vehicle when it's sold as new. It's called engangsavgiften in Norwegian. And in 2006, we gave it an explicit price on CO2 per vehicle kilometer, as in the registration document. And then we have twisted it upwards every year since. And here you can see a story which I called Homo economicus squared. And the square, and it's Homo economicus 1, because you can see that this policy instrument is driving emissions down. In our econometric test, we're finding that Norwegian policy instrument is responsible for 80% of the downward slope. But also Homo economicus 2 is we have these funny jumps, which are in the November and December every year. People who plan to buy emission-intensive cars buy them before the tax price on CO2 in the vehicle goes up in January. There's no doubt that it works. It's also no doubt that it's expensive. Here is CO2 emissions per vehicle kilometer in new vehicle sales in Europe, and you can see it's traveling downwards all over. But in Norway, it goes faster from 2006, and that's when we started with this very powerful instrument. So highlights, we find the tax responsible for 4/5 of the CO2 slimming of cars, about as much from within segments, so let's say between small and large SUVs, as from between segments, so that's for instance from mid-size to small. When a representative car price is raised by 10% through CO2 price in the registration tax, the representative emission intensity is reduced by 5%. Sounds like a lot, but it is actually quite expensive. It means, for instance, that if you want to get emissions down by half, you need to do a lot more than raise car prices by 10%. So it's costly also. It's about 10 to 100 times the quota price in Europe. So this means that we cannot justify this unless we really think that we're changing the world. We are moving technologies, we're showing the world that this is the way to do it. And if this price doesn't change very much downwards pretty fast, the world is going to be very unimpressed, but they will have learned something. So we're saying the policy should move towards neutrality. We don't think it's necessary to have electricity exceptions. We think this is a pretty cool instrument as it is. We need to move towards managing user costs, so that also electric cars pay to get inside Bergen, for instance. And we need to manage them with respect also to urban environment and congestion, so that we get most of these expensive, cleaner cars in our polluted cities. So highlights. I'll go through that. I'll have to move faster. Now let me move towards biofuels. This is my friend Trygve Refsdal, forstmann and very experienced forest worker in Voss. And he comments on a study from Sweden. And he basically says, the study in Sweden concludes that they take out as much forest in Sweden as we take out oil in Norway. And he says, well, it's a wrong comparison because there is 2.7 times as much energy in a ton of oil as it is in a ton of forest, a ton of biomass. Also, you can use perhaps 60% of it. So if we get from 85 to 31, we get from 31 to 19 tons per year when you take account of this. If you want to refine this wood, rather than burning in your stove, as I do, you take away another 2/3. So in other words, perhaps it is 5 megatons that could be used for biofuel if you look at Swedish forestry in this way. In Norway, our growth in the forest is about 1/4 as large. So in Norway, who admittedly is a very fossil-intensive country in resources, but we're also a land-intensive and forest-intensive country. But the forest couldn't turn out more than 1% or 2% of what we produce in fossil fuels in Norway in terms of energy. So both Trygve and I are much more excited about the potential that the forest has to store carbon than the potential that it has to power our transportation sector. And as you have seen from my other work, I really think that electrification is a big deal. I think that a more effective transportation system is a big deal. I also think that biofuels will have a role to play, perhaps even in road transport, but more clearly so in aviation. We economists do not think much about the idea that you can get a lot out of the forest without, or lot out of biomass in transport without either taking some products that we would use for some other purposes or taking some unused forest, which then will be laid claim on by mankind as opposed to being just pure nature. Nøstbakken, good environmental economist at NHH, she has written a paper where she says biofuel mandates are about as important in pushing up world food prices as our demand for food factors such as population and income. So I think we are going to use biofuels, including in transport. I don't think it's going to be free. I think it has to take some land that we would rather leave for nature if we could, and it will take some land where it's competing with other agricultural outputs. So I do think it needs a delicate hand. Here's an example, a calculation that I have done and which I think is quite telling. Gunnar needs 2,000 calories per day. That is the same as 50 kilograms of oil equivalents per year, not 50 tons, but 50 kilograms. My previous car, which was an ordinary Volvo station wagon, V50, had an annual demand 15 times my body. Or if you say that our car is full of 4 people, then it's 4 times the needs of the people in our household. So if you think about it, we're 7 billion people that we are feeding on Earth today. It may be 10 billion before it stops. I think it will be. But there's 1 billion cars. They each need 15 times as much as a person. So in my view, it's absolutely clear we cannot give food to the car. There's no chance. Maybe 6,000 years ahead if we are less than 1 billion people, but not in any close proximity to where we are now. Some other interesting numbers, in my view, is that if I bike to work, the reason why it's more energy efficient is because I don't carry a very heavy vehicle. So if I bike, payload is 90% of what travels. If I ride a car, it's the other way around. Payload is 5 or 10% of what travels. And actually much of what it takes to make transportation energy efficient is to look at numbers such as this. Much about greenhouse gas policy, in my view, is going to be about the energy economy, such as tons of oil equivalents per vehicle kilometer, per passenger kilometer, or per ton kilometer. Electricity helps. If you look at the numbers, there's no doubt we have more than enough electricity in Norway to power the whole transportation sector. And is it doable? Yes, it's doable. Is it costly? Yes, it looks like it's a little bit costly. Batteries are still lousy and expensive, so they should be small. In my view, plug-in hybrids is a beautiful solution, and it's going to grow. But we need to treat the plug-in hybrids tougher in Norwegian policy than we are doing presently. I think, and we have worked on it, how much carbon could we stack in world forests? These authors, Hansen, Ni, Giske, and Eskeland, we think it's big. Forests can, for many decades, take a gigaton or 2 of carbon just by growing. And in my view, it's also important that the storage in the forest can be extended in quantity and in duration if we take products out of the forest, like lumber, and use it to build schools and homes as the world is developing and urbanizing. One tidbit is mankind is going to build more urban real estate in our time than mankind ever did and than mankind ever will. So if we can learn to build these buildings and this furniture in a fairly durable way using biomass, I think that we should rather look to the forest as development and as storage than as biofuels. Here's an example. You all know perhaps that we've got a pretty cool tall wooden house here in Bergen at Puddefjordsbroen, and now this was in the paper yesterday. In Brumunddal they want to build an even taller one. I actually think that this is something that we could take pride in pushing forward in Norway. It is quite amazing to most people that we have wooden homes here in Bergen, like the previous home we lived in at Nordnes. It was more than 200 years old, and it has the same planks, its same wooden structure as it had when it was built. So can we do that in other parts of the world? Well, I don't know, but I think we can do a lot better. And this material is cheap, so it's only a question of whether we can learn to use it in a durable fashion. Thank you.